So, okay, good, it moved. Otherwise, I would have said chutti from today's session. Because it's not moving, it does not want to have this. Okay, so as Dr. Jindal has already told, it is analysis, and what it is to synthesize the results across the studies. No, but I was asking one question before this. What was that question I asked?
What is
No,
how
not really. How do you explain phenomena? By conducting research? Okay. What kind of research you conduct? Are you angry with me?
Angry, so agree with you. Angry with you.
Yes. So how do you conduct research? Have you conducted any research so far?
Yes.
What research have you conducted?
First rapid experiment.
What was your methodology?
Just
Was it a secondary data or
through
primary?
primary
Okay. How have you conducted that?
through making the questionnaire in Google.
Okay. Next, how many samples?
3,000.
3,000 samples. Okay. And how have you generalized it for the results?
analyzing
No. Analyzing and everything. You have generalized that for which area?
Hubli Dharwad.
For Hubli only. Okay. That's there. So she has done a good job. With 3,000 sample size and then generalizing for only Hubli is correct. Nothing wrong in this. But the problem lies when a very enthusiastic researcher like me will take 100, 200, 300 sample and then he will say X and Y behaves like this in whole of the India. The problem is with that kind of generalization. Are you angry? So, is it right to do that? Do you also see the problem?
Yes.
And what is that problem? If you agree with the problem, then what is that problem? Yes?
Too general.
No, problem. It is my wish, I generalized.
No.
Then what is the problem?
Diversified the result.
Sample not being representation of the population.
Yes.
Good. That is why I am saying he is hero. Okay. When we say sample is not representative of the population, that means that the sample statistics is not very close to the population parameter. This is what your statement means. And what all we are interested is to know the population parameters. And what is the theory? Theory is telling this is the population parameter. Something wrong about it? Do you agree or disagree? I will say sometimes some very, very wrong things and you will say yes, we agree. Then you are caught. So think about it and tell me. The population parameter is what theory is all about. Is it right or wrong? Anybody who will say wrong?
Not always, sir.
Not always, maybe. Then what is that case of maybe?
Maybe there are outliers.
No, outliers and those things are
So
different.
generally what we do, we develop the theory out of the experimental basis on sample data and we generalize it for population. So if it is based completely on census, we can justify the development of theory. But most of the time what we do is...
No, that's not the case. What I am trying to say, in case you know about the population parameter, you know exactly what the population parameter, and you specify that this is what it is. Is it a theory or not? This is what I am asking. He said maybe. And he said outliers. Because we have learned so many terminologies, in statistics and all. So, what are the outliers of a population parameter? Outliers can be there only in the case of samples,
Yes. Yes.
not in the case of population. Okay. Outliers meaning what? Yeah. Okay. So, all of you agree, if we come to know about the population parameter, then we can very well say that this particular revelation, whatever it is a theory.
So, but then too, the theory is again being explored and re-explored, like Lamarck and Darwin, they keep on exploring the theory again one after the other.
What do you mean by theory?
So they develop some theory.
No, what do you mean by just the word theory?
So something which can be accurately predicted after the experimental or research studies, which can generate some knowledge.
You are adding too many masalas in this. This is only plain idli.
So then I don't know.
You know it, you have told it. But then you added chutneys and other things to that, so that we can eat it. I just want to eat plain idli. What is theory? You know it.
It is a statement
Yes.
which predict the relationship between some.
That's all. So if we know about, in case of population parameter, that X and Y are this way related, is it theory or not? If that is true for a population parameter,
Certainly.
that is what I am saying. Okay. Chutneys will come later. Okay. क्या हो गया भाई ये? Use mouse. Mouse is also not working. Should I click? Achha, this is connected, not my keyboard. No?
In your laptop it is working. Sir, upping and leaving.
This is okay. This is not.
Network sir. अन्ना आले कोड connect
No. Does it work? Like I can use my hand to. So you can do this if that can work. Use a chair. Use a chair. So as I was telling in the beginning that instead of the narratives, okay, instead of the narratives that so many studies found positively significant, so many studies found negatively significant, so many studies found non-significant, meta-analysis is a better method. Now do you agree, all of you agree with this kind of thing? But how can you agree without even knowing what is meta-analysis? Do you agree? You don't have to always agree with me. This is precisely I told. Give me 2 minutes, okay? So in your view, meta-analysis must be a very, very tedious, very, very difficult methodology. Should it not be there? When we are talking so much about it, that how meta-analysis is good and this and that. Is it should it be a very difficult method or easy method? Huh? You don't know. Know it. What is there not to know it? As simple. How you can know it? Just asking me. Okay. By asking me, you can know it. Okay. Can I have water also here? What is this? Now it will move. Okay. Yes. Okay. This can be also used. Good. No. Don't worry. I'll use the keyboard. Okay. So I will not go through all these things. These things you will come to know later. Okay. What is this? Yeah. So these are the main steps of meta-analysis. You are doing review of research, what you said in the beginning, find studies, okay? And in the bracket, there is something. What is that? What does that mean? What does that mean? See, actually the problem is, in my class things are very easy. I just want to make it difficult for you. Okay? Things are very easy. At the end of this class, you will say, what was there? But I want to make it difficult for you. Okay? So what is effect size?
Significant, 1%, 5%, 10%.
How many studies we have?
No, not exactly, not
So
exactly.
it can be the number of size of the sample which can be applicable on the topic.
Size, don't look at size. Look at the effect word. In any study, what is the effect that you are looking at? Are you not looking at the correlation? Correlation is what? It is the effect. Are you not looking at the difference? Difference is what? It is effect. If you are looking at chi-square, what is it? It's the effect. All these things what we do? Why do we do? We want to see the effect only, no? And these things, these statistics are nothing but they tell you the effect. So you have to look for the similar effect size. Okay? If it is difference, then you have to look for the studies which are reporting difference. If it is correlation or chi-square, both can be combined also. We will see that. Either correlation, chi-square, there are methods where the findings of correlation and chi-squares can be combined. So we have to look for studies with effect sizes. Okay. If the studies have only some abstract is there and they say only that it is highly significantly correlated and no value is given, then your purpose is not solved. Okay. So you have to find the effect size, you have to code the effect size, okay, code the study characteristics, whatever characteristics that you are doing, calculate the distribution of the effect size, examine the moderators. What is moderator variable?
So this is the, like if we take x and y, this variable or moderators, they generally do enhance, like if they work as catalyst and they may increase or decrease the impact of the end variable.
Correct. So we need to also identify such kind of variables which may be the moderator variable for one good reason that I will tell you later why. Okay. Then draw conclusions and share by publishing. So what do you think? Meta-analysis is very simple. All these steps are difficult or easy? It's easy. Okay. Good. Pardon? Oh, thank you. So what to combine? Can we combine oranges and apples? Certainly not. Okay. I'm seeing slowly some kind of creepiness is entering in the class. Sadness, silence. Okay. Be jovial. Okay. Just enjoy it. Even if it is boring, try to enjoy it. So we have to find out the identical dependent variable and independent variable. As we cannot combine the oranges and apples. Okay. And also that sample should be drawn randomly. Okay. And it is not safe. Okay, these things you can see in the literature. I will not go to all these things. Now, this is what meta-analysis does. Okay, what it does is it corrects the sampling error. Now, again, $1 million question. What is sampling error?
Difference between our population meter and
Wrong.
it's the difference between the mean of difference.
Anybody else? What's your name?
Real.
Priya. I can call Priya.
Yes, sir.
Okay. What is sampling error?
So this is the mistake we commit when we are unable to draw the representative samples as many points. There are types of it, but the major
You are also wrong. I want somebody who is right. What is sampling error? Of course, I said in my class nobody is wrong, but still I want to say you people are wrong.
When we calculate the average of all averages of samples, it is the difference between the population average and that average.
That's also difference.
That is also wrong.
There might
What is
be
right? What is
some
sampling?
bias in
Sample is
sampling.
not random.
There might be some bias in sampling.
sampling.
Now,
When
honestly raise your hand, those who know it for sure. What is sampling error? You two can, 3 of you can also raise it. Raise your hand who knows it for sure. That what is sampling error? I want you 3 of you raise it. You answered. So you 3 of only these 3 people know it. What is sampling error? Can I take it? Others don't know. You know it. What is it?
We are taking sample from our population.
Okay.
So we will not consider as a whole, as a population as our sample. So some percentage error we occur. So that is the sampling error. So
Okay. Yes.
when sample is not the representation of population, then the sampling error occurs.
Okay. How many of you have some idea about what is sampling error? Okay, many of you have. That's good. Now, let us assume that this is the population. I purposely said you people are wrong, okay? Because I wanted others to say what you said was correct. Okay. So let us, because I don't want people to mimic. I don't want people to mimic because somebody said something, I'll also say something. If you know it for sure, you say it. If you don't know, have the courage to say no, I don't know. Okay? Like I don't know your name. What's your name? Shanta. Good. So suppose let us assume that this is the population. And you have drawn the... Oh. Where has it gone? Okay. Did I touch it?
Yes.
Okay. So now suppose if this is the population, you see the population parameter is 13.16. Okay. Now different people among you have drawn these samples and see the sample statistics and compare it with the population parameter. The difference between these two is what is sampling error. Very, very simple. All you people told very tough. None of them understood what you told. Anybody understood what they were telling? Now this is what it is. Exactly, very simple. The difference between the population parameter and sample statistics is nothing but sampling error. As simple as that. And it happens because some of you told it is not representative and things like that. Sample, if it is not representative, sampling error will occur. It is bound to occur. Okay. So now, one more beauty you can see. Can you see the difference between this and this? How much is the difference between this and this?
3.
3 something, no? But if you see the difference between these two and this, is it less or more? Why it is less?
The sample size is increases.
Great. As you increase the sample size, another theory that all of you might have learned, as you increase the sample size, the sampling error will reduce. Because if you see the sampling error formula, downwards is root of n. So if root of n will increase, error will decrease. Okay, inversely proportional. So this is what the sampling error is. Then meta-analysis will also, before that, in meta-analysis, how sampling error is reduced? No, now that you know what is meta-analysis.
By increasing the size of effects we use.
No.
Size will be increased while taking meta-analysis.
Size of what?
Samples.
Samples. It's not effect size beta. It is samples. Because when you are combining a number of studies, and let me tell you what meta-analysis means when you are combining. Suppose if you combine, yours was 3,000. Yours study sample size? 100. 3,100. Yours? 200. 3,300. 3,600. My maths is very poor. Go ahead. Add and tell.
400.
Add and tell. 3,600.
4,000.
4,500. Mine is second and last.
4,700. 4,750. 5,000.
6,000.
6,000.
6,500.
6,500. 7,000. 7,500. Now, I am not taking others because they are B class students. Okay.
Actually, when
Okay, I will take it. Let me just double it. 7,500, let us assume that it is 15,000 altogether. Okay. Now, see what is the beauty of it. The beauty of it is, not a single study is a 15,000 sample size study. Not a single study among whatever you have conducted is a 15,000 sample study. But when we combine it, it becomes as if the results are drawn from a study of 15,000. But mind it, here I have combined. But it can only be combined when they are the same dependent and independent variables. Okay. I just assume that all of you have done the same study. Okay. So that is the beauty. That with meta-analysis, without conducting the research on 15,000 sample size, You know, if my guide will say, do a research on 15,000 sample size, I will think that he's either gone mad or he wants to punish me badly, you know, something like that. So, this is the beauty. And another beauty is, when we have combined it, 15,000, certainly, what has happened? Sampling error has gone down like anything. Now the sampling statistics that you will calculate from this 15,000 study, the so-called 15,000 hypothetical study, is very, very close to what? Population parameter. Isn't it a beauty? Yes. Okay, great. Now, other thing is, it will reduce the error in measurement of dependent variable and error in measurement of independent variable, dichotomization of continuous dependent variable and dichotomization of continuous independent variable. This you can understand. What is this? What is dichotomization of continuous variable? You don't know? I'm young, middle-aged or old? Tell me. I'm young, middle-aged or old? Don't go by the color. This is artificial. Middle-aged. Don't tell me middle-aged. I'm old. I'm 58. But when you say young, middle-aged and old, what you have done? You have categorized. And what you have done? No. One more thing that you have done. One more crime in the research has been done. Variability has been reduced of the data. If you take just the age, which is 58 in my case, somebody may be 60, somebody may be 55, everybody is old. So when you say old, even somebody who is 75, when you say old, you are giving 3. 1 to young, 2 to middle and 3 to old. This is how you categorize and score. Am I right? So the variability has increased. Dichotomization means that something is a continuous variable, but the researcher has done it that way. Okay? And he is giving 1, 2, 3 and doing correlation and every other things. Now, do you tell me one thing? The correlation will be more if it is a continuous variable or if it is a categorical variable. In which case it is more? Continuous variable. Because variability is more. Okay? As simple as that. You do disagree?
That's right. I haven't studied dichotomization.
Dichotomization means categorization. That's all. Nothing more. Dichotomize means male female, something like that. Okay. North south, something like that. Okay. And then there is range variation. Range variation is when you have conducted a research for Karnataka and you are also going beyond the range. That is range variation. People do that. Okay. So these things it will eliminate. I will be dealing only 1, 2, 3. Okay. The rest thing you have to study yourself if you are interested in meta-analysis. Go through the publications, research and other things. See how it is done. Okay. Because I am not interested in. Good. Now, how difficult it must be to eliminate the error in measurement in meta-analysis? How? Is it difficult? Don't say no. Because when you say no, I will ask how. It is not difficult. You are right, it is not difficult. Oh, I don't want this. There is no board. Board is left side. Good. Then, but I have to close the presentation. Is it? I can write along with this?
Yes.
How? This one? Where it is? Pen. Electronic pen has to be there.
Yes.
Sir,
Where is it? Thank you. Well, my handwriting is very good. Okay? So don't comment on that. What is reliability? If I say reliability is .8, what does that mean? Don't tell me, give me the definition of reliability. I know all of you have just passed, you have studied, you have given exam, scored very high marks, so you can tell me the definition of reliability. I am very poor in understanding, in remembering the definitions. So I am not interested in definitions. Tell me what do you understand by this statement? Reliability is equal to 0.8.
So when we repeat the experiment out of 10, like 8 times we get the same results, is it?
Same to same. When we are tested.
Actually, that is one, as per your one of the definition of reliability, but there is little more than what you said. When we say reliability is 0.8, you are correct, not wrong, but I want a different definition.
80% of the results are correct. So 20% is still
Okay, that is another way of putting it.
Questions are reliable to our research topic.
What did you say?
Questions is related to our research topic is reliable at 80%. Like
No, this is not to do with questions. This is to do with measurement. Reliability is to do with measurement. Okay.
So it's 80% of variation. The independent variables, but what we have taken, explains 80% of variation.
No, this is, we are talking about reliability of an instrument which is measuring. We are not talking about the regression.
So in multi-setup, if we use the same instrument, like the same repetition of what I said.
See, reliability has two things, no? Accuracy and consistency. You are talking about consistency. I want to know about the accuracy. In terms of accuracy, what does that mean? Yeah.
Every 100 measurements I make 80 times it is reliable and 20 times it will not be reliable.
And what about the one measurement? Whether it is reliable or not? One I have measured once.
Then out of measured ones, you don't have any benchmark or reference to compare.
Is there no tea break?
Yes.
11:30. Okay. See, the problem with all social science teachers and all, they make students' life miserable. Yeah? And because of this, all these definitions are coming. You don't become those miserable teachers, youngsters. You become very, very simple teacher. Okay? When we say reliability is 0.8, that simply means something which is 1, we are measuring it 0.8. You said similar to that, but you said out of 100, 80 is correct. 80 is not correct up to the 100%. Every measurement, what is 1? We are measuring it as 0.8. He does not agree with me. Because you have studied the complex definition of reliability. Difficult to unlearn it and accept a simple definition of reliability. Am I right or wrong? This is what it means, madam? This is what it means? So, how do we correct this? If we know that something what is 1, I have measured it as 0.8. How do I correct it? How can you increase the reliability? Your instrument is only measuring 0.8. It is unable to measure another 0.2. I said how to eliminate the error of this 0.2. Huh? Sample has nothing to do with individual measurements. Suppose if you have measured something as 1.6 with this instrument which is reliable, whose reliability is 0.8. Now 1.6 means what?
The average value.
Actually it is 2. Actually the measurement is 2, but our tool or measuring tool has measured it as 1.6. And now all of you go to class 1. All of you have to go to class 1 or maybe whichever class where they have taught you division. Okay. All that you have to do to make 1.62 is nothing but divide it with the reliability score. Should you not go to class 1 or 2 to learn this? All of you have done masters and PhDs. What for? If you can't make 1.62, stunned? Wrong? Right? No reaction. See, I know for sure now. See, we have two kind of results. We don't have that 0.2 with us. We have two kind of results. One is a measurement, that is 1.6, and another is the reliability of the instrument, that is 0.8. So we have just divided it by 0.8 and we have got our actual score, that is 2. Problem with all the researcher is, how can so simply we can do this? We have to do something very rigorous, very mathematical, and one derivation and integration, and then it should be corrected. All of you are stunned because of this. No reaction. That how this can be so simply done.
Is 1.6 a parameter?
1.6 is measurement. Suppose I measured your attitude towards the state government and the score has come 1.6. And the scale with which I have measured it is only reliable up to 0.8. So what your actual score should have been? It should have been 2. But since I have used this, okay, I'll take another. Suppose. What is your height?
4.9.
Let us make it 5 for easy calculation. Okay. Sometimes we should tell lies. Just like girls will not tell their real age, sometimes heights also you should not tell. So for me you are 5 feet. Now suppose, assume that this foot ruler which has 12 inches, my foot ruler is 10 inches long. And marking is not done, so I don't know whether it is 10 inches or 12 inches. I am measuring with that. So I'll get a wrong height for her. So all that I have to do is what?
Proper measurement.
Okay. So 1 foot I am measuring as, let us not say 10, let us say 9. So that calculation wise it is easy for me. So 1 feet is only 3/4 of a feet we are measuring. Okay. So that is what we are doing. So similarly here also, if the scale itself reliable is only 0.8, we are actually, what I told about your attitude towards the state government, 1.6 it is measuring. So I divide it by 0.8 and I get your true score. Okay. So this is what it is. Okay. Back to my slides. I don't know. You have only taken it away. Good. So very simple. Both the things are simple. Sampling error we can reduce by combining the studies, and measurement error we can correct by dividing it. It's angry with me, I tell you, right from the very beginning. She is not angry. I also want to say the same thing, what you thought. See, this is precisely what was I explaining. If something is reliable 0.99, you divide it by 0.99, it makes it 1. Something is reliable 0.95, you divide it by 0.95 and it makes it 1. Okay? So it corrects. This sampling error I have done. Now, these are the initial, before this glass, some name, glass something. Okay, no, glass is his title. In 1975, he gave this meta-analysis. Okay, and in probably in 81, Smith and Hunter, they give these methods. Okay, you can search literature if you like later on. Why?
This is not.
What is happening? Why blank is coming? Oh, no, it is not empty. Is it empty?
Sir, use kind.
Oh, this one? How come something has been done? No man, I have so many things there. No. Can we go to that file? No, yeah, file. Yeah. Animations.
Animations are not working on the screen.
Fill up the note.
Just you ask him not to go for a blow up. Just we can have just file open, and then from that also I can explain. Don't go for slideshow. Yeah. Okay.
At first file open.
I'll open it. No issue. He does not know.
Double click.
I have so many files, I don't know where is my file. Good. No, there are some. Okay, this we can use now. Okay. It is becoming fun. What is okay. Here also it's not showing.
So the animations are not working in that big one.
No, but I have all my these things here only in these slides. Huh?
Projector can be used.
We can use projector.
Yes, sir.
Please arrange for one. She wants to have tea break, not me.
No, sir. What she said.
No. She is the one who is telling, not me. You cannot blame me. She is telling we'll take a tea break.
Because they need a time to adjust the project.
We will waste the time. We can have tea.
She is also agreeing with me. It's not me. Who else is agreeing? So only 3 of you will be allowed to go and have tea, rest will just sit here. Okay, is it okay to go for a tea break? But it is only okay if there is tea. Otherwise it will be only a break.
Let's go for 3 days.
Tea is available?
Yes, sir.
And for me it should be without sugar. I am 58.
I think kasha is this. Not tea, kasha is this. Sugar kasha is
What is that? मुझे खुद नहीं पता है मेरे स्लाइड में क्या है. Now this is sorry, let us come back again. Okay, that effect size what we were talking about. Okay. So these are the common two effect size, that is correlation and mean difference. Okay. So these are generally in meta-analysis. Research papers, you will find these two statistics being addressed. Okay. Yes. So the first step that I told you is like pulling everyone, sampling error is reduced. Second stage is eliminating the error in measurement of dependent variable. Okay, and for that what we were doing is, जोर से बोलो बेटा, you just had tea. Yeah, बोलो, tell me. You understand little bit Hindi, ना? बोलो and all चलेगा ना?
Score divided by
Reliability, exactly. So first what we are doing is, we are having a weighted mean variance of the correlations, where NIs are the sample size, okay, and RIs are the effect size. Okay, the effect size in this case is correlation. Okay, so correlation of study 1, 2, 3 all, and divided by mean of sample size. So what is the advantage of this, doing this? What is the advantage of doing this? वो मेरा फेवरेट लड़की कहाँ चली गई? 3000 वाला. She'll come? No, Why we are doing this? See what happens now when we study very complex things, simple things become very hard. Okay. This is what is happening in this class now. But if your basic concepts are clear, then only complex things will be more clearer. Okay. Otherwise, can we apply Pearson correlation on categorical data? You said yes? You said no?
Yes.
Why no? This is what happens. Actually, this example why I am saying, not that I want to make you understand or belittling you, but this is what I want to tell you. When you don't understand the fundamentals and basics, you are bound to commit mistake. C is going to use Pearson correlation with categorical data. You don't use it. उसके लिए अलग correlation. Okay. Coming back to this. So what is the advantage of this? multiplying each study with the sample size, the correlation value of each study multiplied by sample size, and then dividing it by the total sample size. This is not average, sorry, this is total summation of all sample sizes. Come on! That is why I am missing my 3000 girl. Where is that girl? Anyway, you have used 3000 samples and she has used 50 samples. Assuming that both the studies are on the same dependent-independent variable, her correlation value is 0.8 and her correlation value is 0.6. What is the average of these two studies correlation? 0.7. But actually, do you think it will be 0.7? Why?
Sample size is different.
So what should be the average of it?
The difference also 0.1.
Pardon?
No difference among two samples because the minimum is average is 0.7 but 0.6 and 0.8 difference is 0.1.
I am leaving this class. I do not understand what he said. Answer is right, but what is the reason that 0.7 is not the mean? What is the reason?
Sampling error.
Not sampling error. Fundamental सिखा दिया इसका मतलब.
Size of the sample is different.
Yes, but what should be the indicate me? What should be the average correlation in this case?
Nearer
0.8. Yeah.
Nearer to 0.8.
Nearer to 0.8. So what I will do is 0.8 into 3000 plus 0.6 into 50 divided by 3050. Now that will be very near to, as you said, 0.8. Maybe 0.79 or somewhere, 78 or 79. Not 0.7. So when we are trying to eliminate the sampling error, we will also multiply it with the sample sizes, because 3000 studies correlation and 50 sample correlation strength is very different. The sampling error in your case is much more. The sampling error in her case, in your case, is very less. Okay? Do you get it? Then you have to ask it. Then only you can get it. What you did not get it? Tell me. I think Professor Jirli has already told that you have to stop me and ask. And so far, Dr. Sir, nobody has stopped this Rajdhani train. Okay? What you have not understood, tell me. See, if you have not understood, then you should know what you have not understood, so that I will be able to explain as easy as that. I thank you for having courage to say I have not understood, but please tell it. We can't stop at this station for very long. This is Rajdhani train. You have to come out. What is that you have not understood? Tell me, so that I will explain.
Correlation of the trouble.
She told she has not understood, not you. If you can read her mind, then okay, you can tell me. Okay, let me read your mind. Fine. Now suppose I calculate average age of this group. How many of you are there? 3, 6, 7, 10, 13, 15 and 18. And suppose you are 18 of you, and I suppose I will not take out of you. Only these 6 people. Average age of these 6 people. And average age of you 18. Let us assume it is 20, and these are 5 people. Now if 20 people's average age is 25, and these 5 people's average age is 30. Not that all of you are so old, but for example. So what is the total average age of this class? Is it, what did I say average age of this group? 25 and 30. So what is the average age of the whole group? Don't tell me, let us check. Don't tell me. Yes. What is the average age of this whole group? This is not very difficult question I have asked you. Tell me quickly. 27? You can use your calculator if you want. You can use the calculator. You are going to tell me what is the average. Use the calculator.
27.1.
What?
That's 27.5.
Sir, it depends upon the number of that.
Do it and give me the number. How much it is? It will be 25 into 20 plus 30 into 5 divided by 25. What it is? You need to calculate and tell me. I will not ask anyone else. You have to tell me. 20 into 25 plus 30 into 5 divided by 25.
26. It is 26.
Huh? 26. Now see, this is what this says. That average of the whole class is not 27.5. The average of the whole class is your average is into the weight. Weight is 20. And average age of this group and its weight, that is 5. And divided by the total number, 20 plus 5, 25. Okay. This is precisely telling the same thing. 3000 into 0.8 plus 50 into 0.6 divided by 3050 will give the correct average correlation. And its variance will be calculated like this. This is a common variance formula. Is it understood? I am very, very happy that C asked, because at your cost, many of them have understood previously. Many of them have not understood what I told, but they were all mom. You all should clap for her courage to ask it, that I don't understood. Good. Please ask, okay? Please ask. Otherwise, the whole purpose of this session will be defeated. And as I told you, nothing is wrong in this class. What more you want? Okay? So now you got it. Why we have multiplying and dividing by the sample sizes? So that exact weightage is given to each of the correlations. Okay. Now, what is confidence interval? All of you are going to deposit your degrees back to your university. Okay.
95% of the data is explaining the result, other 5% can be affected.
No, beta. Little more thinking. You are coming to that track, but that is not going to Hubli. It is going to
95% we can rely, so now there is a chance of 5% here.
Okay, that is correct. But still, what it means? That is 95% significance means 95% correct, 5% wrong. That is okay, good. But what it means?
95% of the samples.
Whether it is happening by chance or there are some relationship.
What is happening?
That probability of something.
Not something. What we started from the beginning. Sampling statistics and population parameters.
The estimate.
Yes.
The estimate we get is 95 times correct, meeting the population parameter and 5 times.
That is why I am saying you are my hero. Okay. Exactly correct. See, we all make mistakes by reporting that the correlation of my study is 0.8. Don't say that. Don't say that. From this day onwards, none of your results should say that. None of your research papers should say this. All that you should say is that with 95% confidence interval, the correlation value lies between R, that is, we have calculated, mean correlation. Mean correlation plus minus this. Okay? So what happens is,
It's a pen.
this one?
Yeah, you can write here.
Here itself. Oh, great.
Yes, sir, you can
Huh?
write.
I write?
Yeah.
Okay. So what is happening is, now suppose this is population parameter. Okay. And this is your sample statistics. Don't consider this. My other finger is touched there. Okay. So when we report, we are reporting that this is the correlation. This is the population parameter. We are reporting that. That is point estimate. Correlation is nothing but the point estimate. Point estimate, all of you understand, okay? But if I use this 95% CI, confidence interval, I will not report this, rather I will report this. This is the sample statistics, and I will say the population parameters lie between these 2 points, because this is plus R, mean R, and this is minus mean R. Okay, so this will give me two intervals. Am I right? Okay, and now I am saying that the sample statistics, the population parameter lies between these 2 points, plus and minus R, whatever. Okay. Now you tell me, actually, isn't population parameter lying between these 2 points? And I am 95% confident that the population parameter will lie between these points. Isn't it lying between these 2 points? Who said no?
Yes.
No. Don't be afraid to say no. You said no?
No, I said yes.
Penalty lagega. Okay. Who has understood this? Who has not understood this?
So can you?
Yes, good, better. Very good. At your cost. Now everybody is going to pay her money and her money. Some 10 rupees each. Okay. See, when we report that correlation value is the single point, you are actually reporting like this. This is only, suppose it is continuum, you are only reporting this point as correlation value, which is, say, for example, 0.086. Okay? And correlation lies between, say, 0 to 1. Okay? So suppose this is what you are reporting, but your population parameter is somewhere here. Let us not consider this. Okay? If the population parameter is somewhere here, so we are wrong in reporting like this. Aren't we wrong? Because it is not matching to the population parameter. We are saying, with my sample study, I have found that correlation of X and Y is this particular point. But do you think that statement is correct for the population? It's not. So how we can make it correct? We can add and subtract this. This is your variance. This is the sample number of studies. K is the number of studies. Okay. So we add this, and then instead of point, this will become this thing. And undo everything. Oh. How to run?
Clean options.
My hand is also good. Now again I'll do it. I'll do it. Good. I'm making a bigger one. This is the correlation value 0 to 1. Population parameter is somewhere here, say 0.9. Okay, and you have found somewhere here, say 0.82. Okay, so when we are giving a point judgment, 0.82 is not equal to 0.9. And it is a wrong statement. Am I right? But if I make a confidence interval of this point, which is something like this, and I say that with 95% confidence, I can say that the population parameter, and suppose this is 0.82, okay, and 95% is, say, 0.92, and here is 0.72. Suppose, let us assume that way, okay. When we have done plus minus this, it has become 0.92, 0.72 and 0.82. Now, is 0.9 in between these two?
Yes.
0.72 and 0.92?
Yes.
Is it there or not? Yes or no? Everybody tell it.
Yes,
It is there or not?
Yes, sir.
It is there or not?
Yes,
It is not saying. It is there or not?
Yes, sir.
Okay. So, now with 95% confidence, I will say that the population parameter lies between 0.72 and 0.92, and I am 95% probably correct. Still 5% error is there. That population parameter can be outside this range. But in 95% cases, I am correct. So what you would like to report? Point estimate or the interval, confidence interval?
Confidence interval.
Isn't it good?
Yes, sir.
Good. Now you understood better? And the sampling error variance has to be calculated in this way. I am not going into how it is done because I am anyway giving you a software to do all these things. Okay. But the problem of software is you have SPSS with you and you apply each and everything. You don't know the fundamentals. Whether Pearson correlation should be applied to the categorical and this should be applied to that or not. So you need to understand the fundamentals. Only when you understand the fundamentals will you be able to apply it. Calculation is not a big deal. Understanding what to calculate is the big deal. You know the driving is not big deal. Whether you want to go to Chennai or Bombay, that you should know. You can't just go out and drive and then think, okay, I will reach Chennai. Will you reach Chennai? You may reach Bombay and become heroines or heroes. So, नहीं बनना है. बनना है कि नहीं बनना है? No, you don't want to. You want to be a researcher. Good. She's telling this is not my cup of tea. Then which cup of tea is yours? Okay? So, this is how the sampling error we will be able to find out, and that also we can correct. Okay? I am not getting into all this formula. You have seen all this formula. So I am not getting into this. Okay? And this is how we will estimate the variance of rho. Okay? And now this is again credibility interval. In case of variance, we want credibility interval, similar to what I was explaining you. Okay, confidence interval. This is credibility interval. Okay, so we have to calculate that also. And this is how chi-square test formula is there. You don't do these things. Okay, software will do it for you. So this is the chi-square test formula is there, where we have to, after combining all the results, and if you see that there is a significance variance in the result based on the formula that I have shown you, that means what? That means what? If you find that some 20 studies you combined, mean correlation you have found, its variance you have calculated, and you found with this formula that the variance is significantly high. So what does it mean?
There is a large difference in the result.
And why that large difference is there?
Because of the sample size.
Okay, that is one thing, but here some other thing is there. I am talking about 20 studies. I am not talking about the sample size here.
Different methodology are used.
No, they have used similar variable, similar methodology, everything similar.
So they are controlling.
Why average of this group was 30 and average of this group was 25? Heterogeneous sample. They are from different population. The 20 studies that you have collected are from different population. Okay. That is why the variability in the correlation value is significantly high. Simple. These are all fundamentals. I am not talking anything very hi-fi. These are all fundamentals. Okay. You got it?
So, as per I understood, like if we take in two data, like effect of some nitrogen fertilizer on some paddy field, if we are considering the study done in UK and study done in India, in this way the variance find difference. Is it? Am I going?
Yes, you are correct. Let us come to not agriculture. Let us come to some social issues. Okay. Now social issues is. Do you think the North India and South India is culturally little different?
Yes.
So some social issues will be different in North and the same study conducted in South will be different. And if we combine this, variability will be more. So what we need to do? We need to segregate. We need to segregate, and that moderator variable is the segregator variable. It can also be studies conducted before 2000, studies conducted after 2000. Before 2000, people like me are born. Yes, one after 2000. still like me. Okay. So, and there can be many other moderator variables. Okay, maybe urban, rural. Some studies conducted on urban population, the same study conducted in rural population. You will find the variability because fundamentally the sample is drawn from two different population and the population parameter is different. If the population parameter is same, this will not be significantly high. So, using the moderator variable, you have to divide the study into subgroup and again calculate average correlation and all those things and find out the confidence interval. Okay? Okay. Study is something different. Okay, so the problem is I am having some formula pasted in this slide and they are not showing. In these slides it is all showing black, whereas there